conventional power generation from the fossil fuel system, there are different options or stages of energy storage in the conversion chain. So, obviously, originally in the fuel form, then after combustion in the heat form, then in heat engine conversion after in the work form, and then the mechanical work is giving as input to the electrical generator, where there is the electricity production, which can be the final desired form of secondary energy and which can also be stored. And in last class we discussed about that higher the level of storage, better it is, or rather comparatively a more fruitful system in a sense, because as the energy flows from in a flow chain, then what happens at every stage there is a conversion efficiency. Say from fuel, if you burn it and make it a combustion, I mean in the combustion process to generate the heat, then automatically the 100% calorific value of fuel can never be used during the utilizations of the heat. So it causes some percentage losses or other efficiency associated with that. So if you can store fuel by demand side management, that means the consumption requirement is reduced. So it's always better. But if anyway, if you are produced already heat, then there also, if rather than the heat to allow to go to the atmosphere, you can have the different forms of storage of heat, either in the superheated state or in the, I mean, the thermal storage is combinations of sensible and latent, or it can be both. Then the heat engine mode, when you have delivered the work, then work storage can also be done in different three options. Okay, am I audible and the slides are visible? I should check because
Yes,
unlike,
sir.
okay, fine. And then in the final electricity form, we have got the capacitance and the electrochemical. And you know this difference between these two. The capacitance is on the basis of the static charge storage system, and electrochemical is on the basis of the chemical conversion of a reversible reaction. During charging, it goes through one particular direction of reaction, and again it returns back the electricity during discharging. So, and the relevance or the requirement of the energy storage with respect to energy conservation, we have already discussed, because this makes a possibility of meeting the gap between demand and supply. So, with this, I think the energy storage, more than this, is difficult to give the exposure right at this moment, because each of these technologies have got involved scientific technology process. Because when you are talking about the heat storage, then also it's, I mean, a lot of options are there alternately for sensible heat storage, latent heat storage, combinations. Each are basically very advanced area of research topic. Similarly, the electricity storage, the electrochemical storage is considered to be the maximum capacity storage currently, but still we are looking for larger electricity storage system, which is the one of the most active driving research just to introduce the so-called requirement of the renewable energy systems. So, I mean, with this coverage of the short coverage of the energy storage in the energy conversion chain, today I'm going to the last possible topic that I can cover and that I think very much important, because that gives another feeling how it is done in industry and how the industry energy conservation principles have also changed. That is basically applying these are data. I mean, you know that the most of the cases the artificial intelligence and database systems are coming up, so IT based systems. So here also in energy conservation these have come up. So I just want to discuss one particular issue with respect to a physical system, how the continuous monitoring or condition monitoring of a system can be also utilized for energy conservation purpose. So let's go to that slide. Today only I have made it rather. I think this will be very much interesting for you people. Last time I didn't taught it. Anyway, so what I have done actually, I'm trying to show you, say one particular, the note I'll give, dictation I will give later, but try to understand the situation. What happens during the operation of any device rather, we are concerned with mostly thermal device because these are related to the so-called fossil fuel consumption. And in thermal device, during continuous operation, in any operation of a particular system, continuous some degradation happens. Degradation means its performance decreases. So it has got several reasons or effective causes. Say I'm taking up one particular example, which is boiler, because boiler is a very common instrument which consumes a lot of fossil fuel input. Examples can be explained with other device also, but that can be a particular department specific or domain specific. Instead of that, though boiler is mostly maintained by the mechanical engineers, but the application of boiler is there in almost several industries. I should not tell it all. Say chemical industries involved, metallurgical industries, they also need boilers. The food processing industries, they also need boilers. So I have chosen sample, as the sample is the boiler. Now, what happens in a boiler? Before going to the condition monitoring, I'm just explaining how the boiler functions. I know that some of these students, like chemical engineering students, might know about the boiler, but the others may be little bit limited knowledge. What happens in a boiler? You know that the boiler basically converts water to steam. So there is a feed water inlet somewhere. Obviously, these are very simplified figure because that's as it is a open elective. I just want to give the basic features, not the details. But in feed water also it needs some water treatment, complicated issues are there, but I'm not going to those issues. From energy viewpoint, there is a feed water that is being fed to the boiler, and finally it is getting converted into steam. And inside the boiler, there are actually three stages of heating. Initially, the water getting heated up to saturation temperature, then the evaporation happens, and then the corresponding superheating, if it is there, it happens. In the fuel part, you need to add some fuel to the boiler. It is mostly coal, but in some cases it can be liquid fired boiler or gas fired boiler also. But the larger boilers are always basically coal fired boiler. So whatever may be the fossil fuel that is being added, I've shown that after combustion, if it is solid fuel, that means coal, there will be certain amount of ash that is finally coming out of the boiler, and some flue gas will be produced. How the flue gas will be produced? This fuel will be combusted with some air input to the boiler. So air from the atmosphere is passed through a air preheater. What is air preheater? Forget about it initially. Think that air is being added to the boiler. So fuel is added, air is added. So what do you expect? There will be a combustion process. In combustion process, what will happen? Heat will be generated. And finally, after the heat generation, maximum amount of heat as far as possible, we will try to make it absorbed by the feed water, so that the feed water in the liquid form is finally getting converted into steam. And the air combustion, the fuel combustion process with air is generating some flue gas. Flue gas means high temperature, different combustion product gas mixture. Here you have given as gas input is the only air composition all of you know. But in the flue gas, some new products, mostly carbon dioxide and carbon monoxide. And if the sulfur, etc. are present, then sulfur dioxide may be also there in the flue gas. If some high temperature combustion process happens, then nitrogen, oxygen, these two gases doesn't combine together, instantly, but at very high temperature they get combined. So NOx or SOx may be available also. In summary, this flue gas has got several gas mixtures of the combustion product, and this may be at a comparatively higher temperature even after exchanging heat within the boiler itself, when with that the feed water is getting converted into steam. Now consider about this flue gas. The flue gas has got also significant high heat content at a very high temperature. So what you are doing in air preheater is, air is passing through the air preheater from the atmospheric temperature. Say today's temperature is around 18 degrees Celsius. So what you will do, if your flue gas is around 200 degrees Celsius, you can just put it here, and heat exchange process, the air may be heated up to, I'm telling maybe, depending on the heat exchange efficiency, etc. here, it may be around 100 degrees Celsius. So you see, initially, though the local air, only you can use the local air. Air cannot be a supply line. Air is taken from the atmosphere. So it will be always entering into the system at the atmospheric temperature. If it is summer, you are lucky, because originally, initially you will get the air at a higher temperature of around 40 or even higher. But if it is winter, automatically your available air will be at a lower temperature, because you cannot control your environment, your atmosphere. You can control your system only. Based on that, whatever the air is coming up, if the flue gas has got sufficient heat content at a higher temperature, you can exchange this heat before the flue gas finally goes to the as exhaust gas to the chimney. A chimney is sometimes also called stack. So the as if the fuel getting burned with preheated air, and then flue gas is generated, and this exhaust flue gas is used finally before getting exhaust to the chimney to preheat the air in air preheater. So what is the advantage? You are in this air preheater is also a very good equipment for heat exchange process and overall energy conservation. And in fact, the air one type of air preheater, the heat wheel, you have been exposed to as a waste heat recovery, because this you can look as a waste heat recovery also. If you don't use the air preheater, then what would happen? This flue gas at a higher temperature with larger heat content would be rejected to the chimney without the air preheater. So certain amount of waste heat would be rejected to the atmosphere without being utilized. By adding the air preheater, what you have done, you have recovered the waste heat from the boiler, or rather from the flue gas coming out of the boiler. So obviously, we have shown the example of the heat wheel or rotating regenerators. The air preheater is nothing other than one of the possible options of the air preheater is the rotating regenerators, but it's not the only one. There are many. I could discuss only one. So, with this structure in mind, I'll give a small text on that. We will see how a boiler performance can be improved by continuous observing different parameters. And this is called condition monitoring. The condition monitoring is a very important aspect coming up in modern engineering. Like health monitoring, the conscious people go to the doctors before getting actually sick. And this is very important, very much required, because once you get sick, then many of the better options of preventing that particular disease is gone. So the treatment for the doctor becomes difficult, and for the patient also it becomes painful, and sometimes it becomes incurable, especially the fatal disease like cancer, etc. So what you can do, the similar concept has been introduced into the physical systems or engineering systems. A boiler, there are possible options of multiple serious failure for which the boiler may be discarded. If you go on continuously monitoring different parameters, how these parameters are changing, like body, whenever there is a very serious disease, say cancer, some of the markers means maybe your cholesterol, maybe a certain type of antigen, maybe certain type of other reactants will be identified that these percentage is increasing very fast. Like for prostate cancer, the prostate specific antigen, PSA they call it, doctors, if it increases very rapidly, then it is a distinct indication that there is a prostate cancer. Similarly, in any device, you have specific particular monitoring parameters, which if you go on continuously monitoring, you can detect earlier that this is the failure or this is the possible option where it is going to fail. And this is called condition monitoring. Condition monitoring is a very interesting subject now coming up in all over engineering applications. We, in energy conservation also, we use the condition monitoring very closely. Let's see what happens, how the condition monitoring issue comes into the boiler, and how we can, the different parameters of the boiler can be continuously monitored to get a better performance with respect to the energy conservation. So I hope that you have already taken this figure, I mean, just to understand the basic scheme of a boiler, you can take from any book. But anyway, this I have just right now made it just for you, because I initially thought that boiler scheme will not be necessary for you. All of you know whatever is happening. But later on, I thought that no, it's a mixed student, so I should give a picture for your examination purpose, just for your standard understanding. And based on this, I will make the discussion. And one thing is still left, that is the ash and the blowdown. Ash is automatically coming from the solid fuel. You can understand from the coal, some ash will come up. What is blowdown? Blowdown is, as I have mentioned, that the feed water is taken, the air is also taken from the atmosphere, feed water is also taken from the atmosphere, atmosphere and local environment. Mostly from locally available river or lake is the water source. But you know that the river water like that is contaminated with many contaminations. So you need to make some water treatment. But after the water treatment also, some impurities remain in this feed water. So that in the system of boiler continuously get deposited. So what will happen? Your boiler tubes inside will get deposited with some, I mean, specific deposits, solid deposits over the time. So this will create a additional layer in the tubes, and these tubes not only affect the heat transfer, because thicker these depositions, lesser will be the heat transfer between the gas and the inside water. But even more dangerous thing is these deposits slowly gets solidified. Initially, they are like some gel sort of concept, I mean gel sort of texture. But later on, they get solidified with temperature variations, because during boiler operation, sometimes high temperature, sometimes low temperature, temperature variations within certain limits always happen. So these are called the scales. In fact, scales all of us are exposed to in our domestic cooking materials also. If we go on continuously heating boiler without washing it very clearly, we will find out that some scale formation will be there in those water boiling pots. Similarly, inside the tubes happens, these scales has got different thermal expansion coefficient than the metal outside. So what will happen? If there is a temperature fluctuations, then the scales inside that is already solidified and the outside tube, it they will try to expand in different with different length during the temperature change. So there will be a thermal stress, and finally this leads to the boiler tube failure. So you have to clean those deposits regularly at an interval, either continuously or at an interval, so that scale formation possibility is reduced to as much as possible. This is called the boiler blowdown process. It is done by extracting some water from the boiler bottommost point. And you know, if you extract some water in a gushing way, means very fast rejection of water, then automatically it carries away some of the deposits which are yet to be converted to solid scale form. This is called the blowdown process. But remember, the blowdown, if it is done with hot water coming out of the boiler, it also carries away some energy. So this also causes some loss in energy conservation. So just now, I do you think that, do you need that this description, or you have understood from the figure and you can understand? Because my objective is not to describe the boiler, but my objective is to how the condition monitoring or different parameters can be applied to a boiler. If this picture is in your mind, then I need not to discuss. Rather, I can go directly to the next slide. What do you think? Okay, no feedback. So I assume that you have understood the entire physical process of boiler: fuel input, air input. Air is coming through the air preheater for a better energy conservation, and then it is, I mean, air fuel combustion process, heat generation. Ash is coming out from the solid fuel, and then flue gas coming out is subsequently used in waste heat recovery device, air preheater. Example was already discussed during the heat wheel and the uh, rotating regenerator principle. Okay. And then you have the so-called the feed water is getting converted into steam in the process, and to remove the impurities of the feed water, you have the blowdown process. So with this entire idea of the boiler operation, let's go to the actual condition monitoring scheme. Now, there are at least 11 parameters we have mentioned here through how you can improve the boiler performance by monitoring these parameters or adjusting these parameters. So before this, just write down a brief preamble. Just write down performance of any device, performance of any device degrades during its use. Degrades during its use. Okay, this continuous degradation process, this continuous degradation process not only affects the performance, not only affects the performance of the device, but also may cause final shutdown of the device, final shutdown of the device. Full stop. Several parameters, several parameters during operation, several parameters during operation of a device may be continuously monitored, may be continuously monitored, monitored, to assess the degree of degradation, to assess the degree of degradation, and simultaneously taking measures to remove, taking measures to remove such degradation, and even to help, and even to help sudden breakdown, sudden breakdown in operation. Okay, this is called continuous condition monitoring, continuous condition monitoring of devices. These are generally data driven, data driven, IT enabled, IT means information technology, IT enabled, ENABLED, IT enabled process with real time data capture with real-time data capture and background analysis and background analysis. To background analysis to conclude the message from these data. To conclude the message from these data. This is similar to continuous health monitoring of human beings by doctors and taking actions at appropriate time taking actions at appropriate time to improve performance and even to improve performance of another human health বলছি appropriate time to prevent disease to prevent disease and even to avoid sudden death Okay, so in summary, what I just want to convey to the message, continuous condition monitoring is a very important subject coming up in engineering applications. And I don't know, some of you may work in that area either in industry or in future research, because people are just, that engineering, how it proceeds. One of the particular subject area of engineering proceeds means that will always have an impact on the other engineering subjects. Like computer science has developed the artificial intelligence concept, and out of computer science, subsequently the data-driven process has been developed by the IT people. And as the knowledge increases, so they have to be identified as a different skill people. So computer science and IT people are close to each other. শুভ, আজকে আবার ক্লাস আছে, দাঁড়াও, ক্লাসের পর 9:30। So Sunday class is difficult actually. Anyway, so the data-driven, processes are almost, or rather, coming out from the computer science people, but still, this now has emerged as an independent subject. Now, what is the situation is coming up in the condition monitoring processes? These new subject developments of data capture, data analysis, and combined with artificial intelligence, the people have started thinking, why not the principles are applicable to the energy systems applications also, not only in energy systems, in any device, engineering device. So now a continuous monitoring system based on the data feedback from the device or the system is a very common applications for most of the advanced system engineering. Now we are trying to see how this condition monitoring can be applied through continuous monitoring of different parameters of a boiler, which has been shown to you as the operational principle. Why you have chosen boiler? Because boiler is a large energy consuming device. So if you can make some good implementations of the condition monitoring associated energy efficiency improvement, then automatically this will lead to substantial energy savings, contributing to the energy conservation. Now the first parameter is stack or chimney temperature. Now think about what happens to the stack or chimney temperature. If I go back to the previous slide, this is finally this exhaust gas or chimney temperature. Now, even if this temperature is high, there is a possibility that this temperature will also be high. So what is this temperature? This is basically the flue gas temperature coming out of the boiler. You have given some fuel. That is supposed to be as much as combustion possible that should happen. That means we call it complete combustion. But complete combustion means entire fuel combustible components will get burnt into the system, releasing its calorific value. So obviously that's the use you are making. If it is an incomplete combustion, some amount of energy content will be lost in the system. So obviously, I mean that will go in some wastage form. So obviously you are monitoring the flue gas, but the flue gas temperature has got effect due to two things. One is if incomplete combustion is there, the flue gas temperature can become lower, and simultaneously the combustion process has happened, but heat transfer from the flue gas to the water has not been successfully done. So, I mean, the heat released due to the combustion process is remaining in the flue gas means your flue gas exhaust temperature will increase. So, one of the parameter is very important for the condition monitoring of a boiler. What is the temperature? How the temperature is varying during the operation of a boiler. So, just write down the point one. Just I'm giving one or two sentences for each of these parameters. Just write down stack temperature. Stack temperature is the, just 1 minute, আমি পাওয়ারটা অন করে দিই। Stack temperature is the temperature of flue gas coming out of the boiler and finally rejected to the atmosphere. Full stop. This depends on complete COMPLET, complete stroke incomplete combustion of the fuel, complete stroke incomplete. It can be a complete combustion, it can be an incomplete combustion. Complete stroke incomplete combustion of fuel, as well as heat transfer between flue gas and water, as well as heat transfer between flue gas and water. Full stop. Complete combustion in boiler never happens with stoichiometric, STOI. Complete combustion of fuel in a boiler never happens with stoichiometric, STOICHIOMETRIC, with stoichiometric air fuel mixture. So I'm sure chemical engineers know what is stoichiometric, but all of you might have heard this particular term during your chemistry in higher secondary. That means if you make a combustion is nothing other than a chemical reaction with oxidant and a fuel. So if you just make a chemical reaction, the reaction equation balanced, then you can find out for 1 kg of fuel how much is the oxidant or the air requirement. Once this ratio is met, this is the chemically perfect requirement for the fuel and air. But this actually, ideal ratio, because in actual combustion process, air and fuel cannot be mixed very nicely, so that always this just stoichiometric air will be enough to burn the fuel. So you need some excess air. That's why just write down, hence some excess air Hence, some excess air than stoichiometric will always be required. Full stop. This excess air helps better combustion, but also carries away some heat of combustion. Okay, just fill excess air you are giving. Why you are giving? Because stoichiometric air fuel ratio would not reach, make complete combustion. So your unburned fuel will be there. It will be an incomplete combustion. So you are bound to provide some excess air, because this is the difference between the pure science and the applied science. Though pure science has perfectly told that stoichiometric air fuel ratio should be enough for the combustion of that particular fuel, 1 kg of fuel, and accordingly how much fuel air will be required. This is stoichiometric calculation, and that's absolutely perfect. If you can make it proper mixing of the air and fuel, every fuel gets the air content or oxygen content. But that will never happen in real life system. So some excess air has to be there. And excess air means what? That excess air will be coming up in the atmospheric temperature. So it will also carry away some heat. So automatically the excess air is required for better combustion, but excess air at the same time reduces the heat availability, because the flue gas, the generated combustion products temperature will be less. So engineers always have to make a compromise. So just write down. I'm not going to explain you in detail how this excess air control is made. There are different options, stage combustions, etc., etc. Those are advanced technology. Advanced issues. I'm not going into those, but just write down. Hence, continuous monitoring of stack temperature is required for better performance. Okay, so you have identified that from the stack temperature observation, like a doctor, the blood pressure is measured, and if the blood pressure is high, doctor has identified something has happened. So these conclusions is done on the background. That means data capturing continuously happens in the data capturing system, and there is a behind calculation or conclusion process, either by human brain or by artificial intelligence. This is the standard technology we are currently employed in the industry. Then next point is the point 2, feed water preheating using economizer. This is rather, I thought that in waste heat recovery process I will explain the economizer, but as I could not due to lack of time, I will just make a short sentences here. What is it? Just write down. Feed water is initially heated with exhaust flue gas, to recover waste heat as far as possible. This is done in economizer. Of a boiler. Full stop. Maximum temperature of water. Feed water. Maximum temperature of feed water at economizer exit, at economizer exit should be less than saturation temperature, should be less than saturation temperature at the boiler pressure. Full stop. Just write down the next sentence. Continuous monitoring of feed water temperature at the economizer exit, feed water temperature at the economizer exit helps to improve the performance, helps to improve the performance of a boiler. Okay, then go to the third point, combustion air preheat. So under the third point, just write down air is supplied to boiler, air is supplied to boiler from local atmosphere, and hence it is at local atmospheric temperature, and hence it is at local atmospheric temperature. If the air, if the air can be preheated using waste heat from the exhaust gas of the boiler, then energy performance of the boiler improves. Full stop. Hence, monitoring air preheat, hence monitoring air preheat is an important parameter. Okay. Fourth is what? Incomplete combustion. This is very relevant issue, because if the fuel sent to the boiler is not going through complete combustion means what? The combustible component of the fuel in a coal, ash is always there. Ash is the incombustible part. It is basically some many metallic oxides that are not combustible. But the ash has got majority of the combustible components as hydrocarbon fuel. So hydrogen is there, carbon is there. In addition to that, in some of the coal varieties, there will be some sulfur, there will be some mostly sulfur additional as the combustible component. Now, what happens in the carbon, sulfur, and the carbon, hydrogen, and the sulfur, depending on the coal composition, these three constituents can vary. But the incomplete combustion means you are not burning these combustible substances fully. So what is happening? The heat release is less. So obviously your available heat for conversion of water to steam is also less. So, how can you identify the incomplete combustion? Just write down incomplete combustion. Incomplete combustion means loss of some combustible, combustible, loss of some combustible parts of a fuel and this causes overall inefficiency significantly. Next sentence, incomplete combustion can be identified by continuous monitoring of flue gas composition and analysis of ash. Full stop. More fraction of carbon monoxide CO in exhaust gas indicates incomplete combustion. Full stop. Similarly, presence of carbon in ash, presence of carbon in sample, presence of carbon in ash sample also indicates incomplete combustion. Next sentence, proper measures may be taken if these two are identified. Okay, so what I just give in a very small general message, because this is an open elective class, I'm always restricted not to go further in technology issues. The issue is you have the combustible components, carbon, hydrogen mostly. In addition, sulfur can be there. So hydrogen can never be available in the ash part, because if it doesn't burn, automatically it generally hydrogen burning in completion is completely impossible, because it is so spontaneously it burns, it finds out its own oxygen by itself. But the incomplete combustion possibility is there in the carbon combustion process. So if there is no combustion of that carbon content, what happens? It is actually identified in the ash sample. So in any big boiler, it may be a power plant boiler, maybe a process boiler, always the sample collections of the ash is a standard protocol, and go on examining those in the background in the laboratory, where if you find out the carbon particle available in the ash, then you have to be very cautious, because some causes of incomplete combustion has happened. Similarly, in the flue gas that is going out of the boiler is also tested continuously with online chemical flue gas analyzer or gas analyzer, where the percentage of carbon monoxide is continuously very cautiously monitored, because if carbon monoxide increases means what? The incomplete combustion of carbon, generates carbon monoxide, but complete combustion always converts it into carbon dioxide, and in that process you have certain amount of heat release. So obviously the availability or percentage of carbon monoxide means it is causing incomplete combustion. So I'm just telling you the symptoms, not the measures what to take. I'm telling proper measures should be taken. But what is proper measure? It's difficult because many technological options are there. You have to control it, increase the turbulence, you have to increase the so-called the temperature rise, stage combustions. So these things, I'm not going into those things, is not possible in a mixed group, but you can identify that incomplete combustion can be identified by two aspects. One from the flue gas analysis of carbon monoxide fraction, and at the, ash sampling, where you can find out carbon, solid carbon in the ash itself. Point 5, excess air control. This is a very important parameter actually. Just write down, excess air is always required. Excess air is always required for complete combustion of fuel. Full stop. But it simultaneously decreases the flue gas temperature inside the boiler, as excess air is always supplied from the local atmosphere at lower temperature than inside temperature of the boiler. Proper monitoring of excess air. Proper monitoring of excess air is a critical parameter for boiler performance. Just for those who are very much curious, I can tell you that this excess air control logics, because it's a basically chemical processing feedback loop. So the excess air control logic is very interesting because this has got simultaneous effect on many parameters. And honestly speaking, you have to make a full simulation of this chemical reaction process, and then only you can conclude what should be the effect. Say you have noted that the oxygen percentage in the flue gas is increasing slowly. So why it is increasing? The cause is air supply side. You have some measured parameters or monitoring factors, and then for this fuel ratio is also controlled accordingly in the system itself, but still it is increasing means there is some incomplete combustion and you have to increase the excess air. But again, you have to find out the reason, because unnecessarily increasing excess air without having any effect on the full combustion process will contribute to less of efficiency, because the air is getting added always at a lower temperature than the boiler inside temperature. So there is very interesting, research publications are there how the excess air should be optimized in a boiler. But I'm rather helpless here not to explain those things, the basic physics. I'm just going to remind you that the point 5 is the excess air control. Number 6, radiation and convection heat loss. What does it mean? Just write down, boiler inside temperature is much higher boiler inside temperature is much higher than its outside atmospheric temperature. Hence, there is always a possibility. Hence, there is always a possibility of heat loss from the outside surface of a boiler. It needs it needs heavy insulation, HEAVY, heavy insulation on the outside surface of the boiler. Continuous monitoring, next sentence, continuous monitoring of outside temperature of this insulation is required to reduce radiation and convection heat loss from the outside surface. Okay, this is rather simpler to understand because this there is not much of rather the engineering or technology in it. Only thing is, always as the inside temperature is some maybe more than 1000 degrees Celsius, but normal atmospheric outside temperature, if you assume it to be around 25 degrees Celsius, then you can have always have an idea how much temperature difference is there. So outside the boiler, always you will find out there is a heavy insulation. Insulation bricks are there, and design of insulation is also a technology. I mean, proper insulation design and then making the thickness and proper material in between. There is air gap. All these things are involved part of a boiler design. But what in condition monitoring you can do, you can continuously monitor the outside temperature of those boilers because maybe you cannot identify, but there is some in between leakage what has caused the flue gas to coming out up to the almost outside surface of the boiler. I mean, even after the beyond the insulation. So what obviously continuously loss will happen. So monitoring the surface temperature of a boiler is an important conditioning parameter. Next, 7, boiler blowdown control. So already I have explained what is blowdown because as I have just, I'll give a short note on this, just write down. Though feed water treatment is done to reduce impurities in feed water to the boiler, to the boiler, but some impurities will always be there and will deposit inside tubes to decrease the performance and final failure of the boiler. Hence, blowdown, blowdown is the process of gushing out, gushing, of gushing out water, gushing out hot water, gushing out hot water from the bottommost point of the from the bottommost point of a boiler to remove deposited impurities. As blowdown blowdown process rejects heated water, it affects the boiler efficiency. Full stop. Hence, control of boiler blowdown must be optimized for removal of impurities and simultaneously not losing much heat. Okay. Here again, I'm just stopping here because boiler blowdown has got several control principles. We can make continuous blowdown so that some amount of water will always go out with a very controlled small amount. It can be intermittent blowdown, and in the blowdown process also continuous monitoring of water is required. Actually, impurity presence is identified because when the boiler is operating, you cannot identify how much impurities are already there inside. So this is done by electrical conducting process. If the impurities increases, then the ions increases in the boiler. So obviously conductivity decreases, conductivity decreases. So automatically, conductivity increases with the appearance of ion. So through that continuous monitoring of the water conductivity, we can decide how much boiler blowdown process will happen. I'm just giving you just for your curiosity. This is I'm not including in your part of the discussions because I'm just mentioning the process how with the energy conservation so many issues can be involved. But obviously each of these actions has got sophisticated technology with instrumentation and control for implementing these things. And there is a basic understanding of the entire physics phenomena to adopt these measures. Number 8, reduction of boiler steam pressure. So what do you mean by this? Just write down boiler efficiency. Boiler efficiency is maximum at its designed pressure. Is maximum at its designed pressure. Full stop. Any higher pressure operation, any higher pressure operation of the boiler degrades its performance drastically. Degrades its performance drastically. So, reduction of boiler steam pressure. So, reduction of boiler steam pressure whenever possible is always desired. Okay, this is just to remind you that higher pressure operation of a boiler is possible, but try to avoid it as far as possible. But how you can avoid it in the industrial system is not possible to discuss here. There are different mechanisms actually, the mixing of different boiler streams and then combining them into a common final feeder line. So these are the options possible. But I'm just giving you the idea that the boiler steam pressure increase means you will have a drastic reduction of its efficiency. So go for the lower pressure operation. If required, you can manage the system. But how it will be done, I'm not going to discuss like other points. Number 9, variable speed control of fans, blowers, and pumps. What does it mean? Uh, just write down, because if I'm getting tempted to talk a lot about these things, because all these technologies are excellent. Each of these can be a very good research topic for several PhD theses, but I can just make you a very small discussion. So what is variable speed control? I mean, just you have to understand that first, then I will just give you the dictation. You know that the devices, rotating devices like fans, blowers, pumps, etc., are not necessarily rotating, that they can be reciprocating also. But these devices has got its, I mean, speed of rotations, or rather frequency of reciprocatory motion. Now, if you need more output from these things, if it is a fan, if it is a blower, if it is a pump, then obviously the frequency will be higher. It's common sense that rotational speed will be higher. But if demand is less, then you have to reduce the operational, I mean, speed of these devices. But there are two ways of doing these things. One is you are keeping your speed at constant speed, but you are bypassing some amount of the air delivered or water delivered to some other chambers. So what is happening? Energy consumption by the device remains same, only you are adjusting the reduced demand by bypassing the main feeder line. This means your consumption of these devices, energy, electricity consumptions of these devices remain same even at lower load. But currently, the variable speed control means whenever there the demand will be less, the corresponding rotational speed will also be adjusted by this for these components, so that the power consumption with reduced load will also be less for these devices. This variable speed drive control is basically the development of the electrical and electronics engineers, but in power plant, which is mostly operated by the mechanical engineers, is a very useful device for energy saving. Just write down. Previously, previously at lower load, previously at lower load, devices like fans, blowers, pumps would run, would, W-O-U-L-D, would run at the same speed with a bypass, with a bypass of these output flow, with a bypass of this output flow of air or water. This process consumed same electricity even at lower load. This affects auxiliary power consumption, AUXILIARY, auxiliary power consumption of the boiler. With variable speed control, next sentence, with variable speed control of these THAC, these devices, significant energy savings can be done. Significant energy savings can be done during low load, during low LOW, low load on the boiler. Okay. So point 9 is basically related to the auxiliary power. Auxiliary power consumption means when you have to run a device, then several devices are attached to that, which also consumes power. So the auxiliary power consumption at low load decreases if we can make a variable speed drive, because variable means at a lower speed, if you can run that system, then it will consume less electricity. But unfortunately, previous practice, it was there actually in power plant. Nobody, I mean, in not only power plant, in process plant boiler operation, earlier process was whenever there is a low load, you can just make a vent out of certain amount of fluid, maybe it air, maybe it water, but keeping the fan speed or the pump speed or the boiler speed at the constant speed. That was the convenient process. But now people understand with load variations, if you can make a variable speed drive and you can control the speed so that whatever energy input you give, that not get lost as a bypass system. So this is now very much mandatory in power plant as an energy conservation measure. Anyway, with the technology development, this is also possible now. 10th point is the scheduling of boiler loading. What do you mean? Just write down because we'll have less time. Mm, if multiple boiler, if multiple boiler supplies steam, supplies steam to a common load, to a common load, then adjusting different boiler operations to match the load demand, to match the load demand, is a critical issue for overall energy performance. Full stop. Next sentence, running multiple boilers at part load to accommodate lower load demand lower load demand is an inferior option than shutting down, shutting, than shutting down one or more boilers with others at full load. However, this is a complex process. This is a complex dynamic process, and should process with predefined logic of operation. Predefined logic of operation. Okay, here in short, if I just tell you, this scheduling of boiler loading point is not related to a single boiler. In many applications, there are multiple boilers simultaneously providing to a common steam demand. Say in many of the food processing or chemical processing industries, this has happened. And then what happens when the load demand decreases? Then there are two options: keep the part load or lower load for each of these boilers to accommodate that lower load, or you can just shut down one of the boilers, keeping the other boilers, operating at full load. Because operating at full load means always that leads to better efficiency. So this is a very dynamic process, and in fact, the scheduling of boiler loading is a very complicated logic process. You have to have a predefined logic, algorithm developed, then only you can do that. Otherwise, it's because shutdown and restarting the boilers are not always very easy also. But it is a good option if it is substantial, significant amount of steam is consumed for a particular purpose with multiple boilers operating simultaneously. Then last one is a very straightforward statement: boiler replacement. The boiler replacement in earlier, before the energy conservation was full effective, people were not very much willing to replace a boiler because it's a costly equipment. But interestingly, now from the energy conservation consciousness, people can directly see how your boiler is performing. So unless you replace it with next 5 or 10 years, your fuel cost will be so high that the boiler replacement can be done in a better way. Just like the people are now, I mean, rather the incentivized by the government to buy his own flats, just giving some tax relief, etc., etc. In energy conservation also, the ESCO model is something like that, because the if the people can be shown, industry people, that whatever inefficiency with this boiler you are having, that means inefficiency means what? You are trying to meet your demand just with additional fuel. So this fuel cost is getting added up over the years. So if you replace the boiler, you can get that. You have understood the concept of payback period. So if somebody can be convinced that 5 years payback period, your investment will give return, then automatically people will agree. So just point number 11, just write down: currently, according to performance, boiler replacement is even encouraged than repairing beyond certain degradation, beyond certain degradation, as savings in fuel consumption can pay back the investment for the boiler, can pay back the investment for the boiler for a shorter period. Okay, so I think the formal course content I end up here. But if you have any queries, please, I'll just wait for, some few seconds if you have any queries. Then otherwise I will go for my next discussion, closing discussion rather. Do you have any specific queries? Okay, if not, then I can just come out of my presentation process, stop presenting, and then we can have the closing discussions. The closing discussions, always I know that subject means examination, question, marks, these are the important issues. But in addition to that, what I feel always that the teachers currently are not providing notes. The teacher's role currently is, because the information is available with click of mouse, substantial information you can find out with any of the keywords. But what the teacher can do is the guided learning. Means I can just try to motivate you towards a particular purpose, how you can find out or analyze those data that you can have or information you can have from the particular field of knowledge. So here also I have tried to do that as much as possible, because I have tried to make in this particular course, as there is not enough of available textbook at all. Not good textbook, not a single one. So it's better that I have just tried to give you the idea what is energy conservation, and then how we can implement the energy conservation in our perspective. And in your real life future career, I am absolutely sure that at least some of you, if not many of you, will be exposed to this important aspect in actual industry, and maybe someone will take up as your research career. I must admit that the online classes is a very difficult option for the student-teacher communication. I don't like it, but I'm unfortunate that open elective, there is no other option. So I also have to accept it. You also have to accept. But overall, the class cooperation was good, I must admit, and I appreciate it. Unfortunately, there was less interactions from the class, because I always encourage the students to interact, and that makes a class more live. Teacher also understand what to what extent students are understanding, and teachers also get inspired for giving more material. But there was not much of interactions anyway. That's the only thing I had. And regarding exam, etc., I must say that my approach is being very much lenient in examination is doing harm to the students. I know that you are seeing different models in your real life experience, and all of you are adult people. Providing marks without learning is a criminal offense from the teachers, I believe strongly. I can help you in learning, not only getting marks, because you will be a crippled future professional in that case. So as per within my limitations of knowledge, I should try to impart as far as possible to you people also. But at the end of the course, evaluation must be very strict, because that is an indicator of how much you have learned. So I know that the people are driven by marks now in the society, but unfortunately, if you get marks without learning, in my observation, that will harm you even more than if you get less marks with more learning, because your career initial starting marks will be important. That's unfortunate for a country like India, where everything is little bit dictated by the marks. But I can tell you, after some 5-10 years of experience, nobody will look back to what percentage of marks you got in that particular subject. They will look into your perception, your current achievement, whether you in academics or in industry, and nobody is going to ask my mark sheet in MTech or BTech. And just my last 5 years publication is the important issue in my professional career, and how many academic activities I have done in last 5 years. So I can just tell you that education is not certain course content and giving examinations and getting marks. Education is increasing your overall mental framework of learning something new. If unfortunately, if you don't have got that feeling from other classes, I'm sure you have got it from other classes too. But if few classes give some idea that getting only marks without learning much of things is a very great criminal offense by the teacher, I strongly believe teachers at least should try to inspire the students to learn even more than it is discussed in the class. And regarding the semester question, I can tell you that as it is, there is no textbook. Your study materials will be quite good enough. I am not going to, because this year I have just skipped that particular combined cycle. Some of your friends were asking some questions about combined cycle, but I didn't cover because last year the electrical engineering bulk student was there, but electrical has decided somehow they have a lot of electives and they have a similar elective on that, on energy efficiency, etc. So they have opted for that rather than this course. So I have also little bit changed this particular course content, avoiding thermodynamics as far as possible, because I know some of the new branches have come up who doesn't know about the thermodynamics subject at all. Anyway, so whatever I have covered is also a good input for all people. I believe so. So after this, if you have any queries, you can make a class on demand. Means if you in the WhatsApp group, you are really interested to get something explained or something like that, I will try to make myself available. I mean, I'm also busy, but obviously I will try to make available, maybe it's not a full class, but maybe half an hour interaction sort of thing I can try. But if you don't ask anything more, I'm also not going to be having any more class. Today the class is over. And lastly, for the semester, the last year's semester question, if you can have, that can be a good guiding model for you people all, how the questions will be set. Okay, so there will be mostly short answer type questions, and some descriptive portions is generally combined just because some of the students are not being that much able to understand the subject, and they can get some scoring opportunity for those the sketches and description sort of thing. Partially, I don't like very much of sketches and description sort of thing, but that I also have to include something just because to give the opportunity of those students who neither attended classes nor tried to understand this subject, I mean, with critical understanding, what you call it. So it's an unfortunate thing, but only description and making some sketches, etc., is not a good way of learning. Rather, analyzing things to understand the basic physics is the most important thing that the teacher should motivate the students. I'm not sure how much I was able to do that. And giving feedback is optional to all people. If you want to keep it confidential, you can give a feedback of your own, because some of the limitations of my teaching, if you can provide me, that will help me for my future improvement. But I'm not making it a compulsory option. But those who like, they can just submit it, I mean, anonymously, or if you want to give something in the email, that's also accepted. In WhatsApp, that's also accepted. But in anonymously also, you can put it to the my HIT Power HIT Power laboratory. There are the staff and my PhD students. You can put it in just in group so that I cannot identify who is giving it, but I can understand some feedback is given. So as university doesn't have formal feedback process, that's a good option for both the students and the teachers, I feel. But still, university is not implementing those things rigorously. I can just give the open option for the feedback if you like to give it or spend some time for giving feedback to my teaching process. That can help me also. Maybe I have some limitations, I couldn't get it. I can get it from the students. Sheikh Muhammad Ali? No. Diptendu Gupta? He was present most probably anyway. Then Sonak Agarwal? No. Anubhav Shah? No. Gitan Dash? No. Vaibhav Agarwal?
Kiran sir, hello.
Gitan Dash present. Okay.
Sir, Gitan Das present.
Vaibhav Agarwal? No. Attendance is really painful for me, but I have to keep some documents. I found out that some of the students who created problem in the exam hall, they are not attending a single class. There is no justification. So not attending class and creating problem during the exam, they are nuisance of the classes, no doubt about it. Piyal Bishash? No. Sangyukta Mandal?
Present, sir.
Okay, thank you. Then Devargo Chakraborty? No. Then Aditya Chakraborty? No, Aditya Agrawal? No. Aditya Chakraborty?
Present, sir.
Good. Then Aniket Shaddar? No. Rupayan Pal? No. Shubham Dash?
Present, sir.
Good. Then Avirup Mandal?
Yes, sir.
Good. Then Shamskriti Tamang Ghising? No, she is not. Riddhiman Bodua? Yes, he is there. I can see. Yes, I can see your icon. Then Oyanavo Maiti? Oyanavo? No. Then Rupam Chakraborty? Most probably present, no?
Present, sir.
Yeah, Rupam, yeah. You are always
Yes, sir.
present, I found out. And then Shan Bishash?
Present, sir.
Good. You are also always present. Then Kaushik Maji?
Present, sir.
Good.
Sir, Jeet Dash in between.